de Broglie relation. Okay. So what de Broglie relation actually? Now if any particle, all of you listen carefully. If any particle of a mass m moving with velocity v, then it will be associated with a wave. That wave equal to lambda, which is h by p or h by mb, h by p or h by mb, h by p or h by mb. Okay, what is p? Now p is basically momentum. Okay, so particle when moves with velocity v, then its momentum is mv, or you can write basically it is momentum. You can write basically it is momentum. P equal to mv, which is momentum. Yes or no? Any doubt is there? No, right? So if any particle is moving with velocity v, then its wavelength associated with that. Wavelength associated with that is called basically de Broglie wavelength. What do you call? Now this lambda is called basically what? De Broglie wavelength. De Broglie wavelength. Yes or no? Clear? De Broglie wavelength. So de Broglie wavelength equal to lambda equal to h by what? H by p or h by mb. Okay. So if you are moving with a high velocity and your mass is less or mass is more, then accordingly your wavelength will change. Yes or no? Or your momentum is more, wavelength is less, or your momentum is less, wavelength is more, because they are inversely proportional. Proportionality is coming. Clear idea? No doubt here. So de Broglie relation you can remember, lambda equal to h by p or h by mb. Now here, if I'll do here, this is linear momentum, remember, linear momentum. Now lambda and p, then how the graph will be? Now graph will be like this. And if I'll do the graph of lambda and 1 by p, then graph will be straight line. Okay, graph will be straight line. So here what I can find? Now your slope will be h. Slope will be h. Lambda and 1 by p. Lambda and 1 by p I'll get graph like this. Now next listen. Little will try to modify these equations. Okay. Little will try to modify this equation. Now all of you listen carefully here. Here you know momentum. Momentum is nothing but 2m into kinetic energy. I can write Ek. Root under 2m into kinetic energy, where Ek is nothing but kinetic energy of a particle. Kinetic energy. And if a charged particle accelerated with v potential, then this kinetic energy will be q times v. That means the same momentum can be written as p equal to 2m qv. Yes or no? What you can write? 2m qv. Now here, if you wavelength or de Broglie wavelength I want to write, I can write it as h by p, I can write it as h by mv, and also I can write it as h by, your root will be there, root under, h by root under 2m Ek or h by root under 2m qv. So these all relations you remember, clear? If I'll do the graph between lambda and, lambda and 1 by root Ek or root Ek I'll get a rectangular hyperbola graph. Okay. And same thing if I'll do lambda and root v, then also same thing I'll get. Okay. If I'll change a little 1 by root k or 1 by root v, then straight line graphs I'll get. So many things I can do here. Okay, many things I can do. You will remember these relations. You will remember these relations carefully. Then, okay, we can calculate whatever they are asking here. Clear? No doubt. De Broglie wavelength and their relations. Any doubt is there? No, right? So if any material particle moves with velocity v, then it will be associated, one wavelength will be associated with that, that is called matter wave or de Broglie wavelength, that is h by p or h by mv. Yes or no? Now you say me here, suppose I am doing the graph lambda and 1 by root ek, root kinetic energy, root kinetic energy. So what I'll get? I'll get a straight line. What will be slope here? Now slope will be h by root 2m. Okay. Now suppose I'll do a graph here, lambda and 1 by root v. Then what is the slope here? Straight line graph will come. What is the slope here? Now slope will be h by 2mq. H by 2mq. That also you can write. Many things you can do. If you remember this relation, many graphs, many things you can do. Okay. Let's again discuss also same graphs in the next page. Okay. So what you understood here? Now here if wavelength lambda, I can write h by p, h by mb and h by what? Tell. 2m ek. Ek is kinetic energy. And also I can write h by 2m qv. 2m qv. Okay. So these relations must you remember. Must you remember. Now if I'll do the graphs, I'll do the graphs here. So let me do the graphs. All graphs let me do. So first I'll do here lambda and root ek. Lambda and root ek graph is coming rectangular hyperbola because inversely proportional, and lambda into lambda here and root v, that also inversely proportional. But if I'll do the graph of lambda and here 1 by ek, 1 by ek, then straight line graph. Then next if I'll do lambda and 1 by root v, then also on straight line equation, and here slope, remember, here slope equal to h by root 2m, h by root 2m. M is mass of the particle. Here slope equal to what? And here slope equal to h by root under 2mq. Okay, this is the slope. So this graphs you remember. Graphs you remember. Accordingly you can identify whatever they are asking. Clear or not? One relation, many graphs are coming. Now next lesson. Next lesson. Suppose I'll change here. I'll do here e root k, here lambda, no changes, same way graph will come. Okay, here root v, here root v, okay, here lambda, same graph will come. But remember, if here I'll do 1 by root v and lambda, same graph will come, but changes is that slope will be nothing but what? Check everyone carefully. Slope will be changing here. It is root 2m divided by h. Root 2m divided by h. Now next, same thing I'll do. Not root ek you take here. Root 2mq. Root 2mq divided by root ek you take next graph. Now root 2mq divided by h. Now if I'll take here 1 by root ek, 1 by root ek and lambda, same straight line graph will come. What is the slope here? Your slope is root 2m by h. Root 2m by h. So be careful about this graphs. Be careful about this graph. Be careful. So when 1 by root v lambda graph you are doing, slope is root 2m q by h. Here when 1 by root 2 equal lambda graph you are doing, slope equal to root 2m by h. Okay, be careful while solving this graph questions. Okay, y-axis, x-axis, what you are taking, you check correctly. What is given in question, you check. Okay, accordingly you do. Now next listen. If lambda is here in y-axis, 1 by root k in x-axis, then slope equal to h by root m. But same slope will change if 1 by root k in y-axis and lambda in x-axis. Okay, so be careful about these graphs. Okay, now next thing. Now for particles, so understand some particles. Suppose I am taking, okay, one particle I am taking electron. If an electron is accelerated in a potential v, then what is the de Broglie wavelength? The de Broglie wavelength will be 12.27 divided by root v angstrom. So in angstrom unit, you remember, you can convert to nanometer also. Okay. Now second, for proton you remember, all of you. Okay, this is your electron you understood. For proton you listen, lambda equal to 0.286 by root v angstrom. Okay, you will give it lambda proton, here give lambda electron, Maurice. Now next, number 3. Next they are asking for deuteron. For deuteron you listen. For deuteron or deuteron, lambda d, that is how much? Now 0.202 by root v angstrom. This one also remember. Now number 4, for alpha particle. For alpha particle, what is alpha particle? Now lambda alpha is 0.101 by root v angstrom. Yes or no? So that also remember. Alpha particle 0.101 by root v angstrom. Clear? Yes or no? So all these values you remember, and along with what you remember, 1 nanometer is 10 angstrom. If you want to convert to nanometer, you convert. You want to convert to angstrom, you convert. So this relation you remember. And one more thing, listen, if 3 particles I am taking, proton. For proton, mass is how much? Mass of proton mp. What is the charge of proton? Charge of proton is plus c. If a deuteron I am considering, mass is equivalent to proton mass, 2 times proton mass, and charge is equivalent to proton charge plus c. So deuteron is 1h2. So remember, proton is basically 1h1. You can remember proton is 1h1. This is 1h2. Now next, if I will come across alpha particle. What is alpha particle? Alpha particle is, mass is nothing but 4 times mass of proton. And charge. What is charge? The charge is 2 times charge of proton. Okay. So what is your alpha particle? Now 2He 4 double plus. This is your alpha particle. This is your what? Alpha particle. Proton and alpha particle and deuteron, all masses and all charge you remember. Clear? Okay. So for electron, your lambda E 12.27 root v angstrom, and for proton, for a deuteron, for alpha particle, okay, and their mass and charge also remember. If you remember this, whatever questions will solve now, you can understand. Okay, clear? So de Broglie relation remember, lambda equal to h by p. After that, see, or so many things are coming here. So many things are coming. Clear? No doubt. This all values you remember. So de Broglie wavelength for a same accelerated potential will be more for electron. Will be more for electron. If they are accelerating electron, proton, neutron, and alpha particle, if they are accelerating with same potential, then electron will have more de Broglie wavelength. Yes or no? You can check with the formula. Clear? No doubt? Okay. Write down. Write down all of you. Thank you.